Hey everyone, just thought I would walk you guys through another example of balancing chemical equations using the algebraic method, just because I find sometimes, reading all that text from the ministry course can be a little bit overwhelming. So I thought it might be helpful if I walk you all through an example and break it down step by step for how I would solve it. So I'm going to use an example that's from your assignment. So you'll already have one of them done. In this example, sulfuric acid is reacting with sodium bicarbonate to produce sodium sulfate, carbon dioxide, and water. So there's a lot of different compounds in this reaction. So what we first need to do, if we're going to balance with the algebraic method, we have to assign a variable for all of the coefficients. So I'm going to do that now. The variable for sulfuric acid for that coefficient is going to be A. Sodium bicarbonate will be B. Sodium sulfate will be X. Carbon dioxide will be Y. And water will be Z. You could choose any letters for these coefficients, right, because they are just variables. But I'm choosing A, B for the reactants and X, Y, Z for the products to kind of keep it consistent and very clearly tell the difference between what's reactants and what's products. So we have our coefficients, and now what we're going to do, our second step in balancing with the algebraic method, is we are going to set up a system of equations representing each of the different elements in our overall reaction equation. This will help us to balance them and in making sure that all of the different elements themselves are balanced. And then once we have that, it makes the whole overall equation balanced. So here's how I'm going to set up the system of equations. I'm using blue just so that it's different and stands out. So what I do, I look for all of the different types of elements in the equation. So I see hydrogen right in the first compound in sulfuric acid, so I know there's going to be an equation with hydrogen. I also see a sulfur in that compound. I know there'll be one with sulfur. I also see oxygen in the first compound, so I know that there will be a compound. There'll be an equation for oxygen. Now I'm going to look at the next compound. I see sodium. Okay, that's the first time I'm seeing sodium, but I know there's going to be an equation for it because this is in the overall reaction equation. So we have sodium. Hydrogen, yep, we already got hydrogen. Oh, carbon, and carbon is new. So there's going to be another reaction equation for carbon. So then I'm just checking to make sure that there are no other unique elements. All right, and we're good, that's it. In this equation, overall, we're dealing with hydrogen, sulfur, oxygen, sodium, and carbon. So what we now have to do is we're going to look at each individual compound and count the number of atoms of the individual elements to set up our system of equations. And this is what I mean by that. So in sulfuric acid, we're going to start with hydrogen to figure out equation 1. In sulfuric acid, I'm looking and I'm seeing there's 2 hydrogens. So 2A, right? For whatever coefficient A ends up being, you would have to multiply that by 2 to get the number of hydrogens. So that's why I'm saying 2A. And then we'll look at B. How many hydrogens are in sodium bicarbonate? There's 1. So I'll say plus B. Again, 1-to-1 ratio, so we don't need to put a coefficient in front of the B. Now equal sign, I'm putting equal sign because we know that whatever coefficients appear on the left side of the reaction equation are going to have to balance out with those on the right side of the equation, right? So that's why we have an equal, we have a balancing, where you're thinking of it like a scale. So 2A plus B, that is going to have to equal the hydrogens on the other side, right? Because we have to have the same number of hydrogens on both sides of the reaction equation. So, are there any hydrogens in sodium sulfate? No. None in carbon dioxide either, but there are 2 in water. So 2Z. And again, I'm saying 2Z because for whatever coefficient that Z ends up being, you would have to multiply it by 2 to find the number of hydrogens. So that's our first equation, 2A plus B equals 2Z. That's our equation for hydrogen. Now we'll move on to sulfur. We're looking at sulfuric acid. I'm seeing 1 sulfur, so we can just say A, 1A. No sulfur in sodium bicarbonate. How many sulfurs in sodium sulfate? There's 1. Right, equals because we're moving to the other side of the reaction equation. I see 1 sulfur. I see no other sulfurs in the equation. So we're good. So it's 1A equals 1X. That's our system, that's our equation for balancing the sulfur atoms. Now we'll move on to oxygen. So in sulfuric acid, there are 4 oxygens, so 4A. There are 3 oxygens in sodium bicarbonate, so 3B. 4 oxygens in sodium sulfate, so 4X. 2 oxygens in carbon dioxide, so 2Y. And 1 oxygen in water, so Z. And that's our equation for oxygen. Now sodium. Sodium first appears in sodium bicarbonate, and there is 1, so B. And then we'll look to the other side. For sodium, we'll look for sodium sulfate. I see 2 sodium atoms in that compound. So we know that B equals 2X. And now we'll do our carbons. There's 1 carbon in sodium bicarbonate and 1 carbon in carbon dioxide. So that's how we've set up our systems of equations. These equations tell us what the coefficients will have to be to balance out all of the individual elements themselves, to balance out all those atoms. And this works because once we find a coefficient that balances all of the atoms, automatically you have a balanced overall equation. So our systems of equations is done, and we can start solving for all these variables. What we first do, and what you're recommended to do, is set A equal to 12. You can choose any number to represent A, and you can pick one of the variables. You're allowed to do that because we're looking for a proportion. So whatever number you set A to be equal to, that's going to explain what the other numbers are in relation to A. Okay, it's about a proportion. That's why we can choose A equals 12. I recommend picking A equals 12 just because there are a lot of factors that go into 12, right? There are a lot of 12 divides evenly by many different numbers, so that's why 12 is a good number to choose. So we have A equals 12, and now we're going to sub that into different equations to find all the other different variables for the coefficients. So I'm going to start with subbing A in equation 2, because I see that it's a very short, simple equation, A equals X. If we know that A equals X, and we know that A equals 12, then that means X equals 12. So now we also have the value for the coefficient X. So we have 2 of them done now. Okay? We also know that while A and X may not equal 12 in the final overall balanced equation, we know that those coefficients are the same, right? They have the same proportion. So keep that in mind. Now we have A and X, and I'm looking for what's the next system of equation I can solve with my variables. And I'm looking to equation 4. So we're going to sub X equals 12 into equation 4. We have B equals 2X, which is the same as saying B equals 2 times 12 because X equals 12. And that means that B equals 24. So now we've solved for B. While B may not end up being 24 in the final balanced equation, what we do know is that the coefficient for B is going to be twice as much as the coefficient for A and X. We've solved for that proportion. So now we have A, B, and X, and I'm looking for another equation that I can sub in one of my variables to solve for another. And I'm looking right away to equation 5. Because we are told here, we know that B equals Y. The coefficient for B has to equal the coefficient for Y. So if B equals 24, that means that Y equals 24. and we found another proportion. We know that b and y will have an equal value for their coefficients because the proportion is the same. We also know that the proportions are such that the coefficients for b and y are twice as much as a and x. So now we've solved all the variables except for z. And what you could do here, you could look for the equations that have z as a variable, either 1 or 3, and you could choose either. You will still get an answer for z. I'm going to choose equation 1 just because there are fewer variables and it will be quicker to solve. So 2a plus b equals 2z, and I'm rewriting that as 2z equals 2a plus b. Now also, to solve for z on its own, we're going to divide both sides of this equation by 2, right? Divide both sides by 2. The 2 cancels out on this side, and then you're left with z equals 2a plus b, all divided by 2. And then we sub in our variables. 2 times a, if a equals 12, that's 2 times 12, plus b equals 24, divided by 2. So we get 24 plus 24 over 2, or 48 divided by 2, which equals 24. So we know that z equals 24. So now we've solved for all of our different coefficients. We have all the coefficients done. And then what I like to do last is I set up all the equation coefficients in a separate part of my solution because we need to reduce everything down to lowest terms. And that'll make it really easy to do that. So if I know that a is 12, b is 24, x is 12, y is 24, and z is also 24, I'm looking for a number that all of these coefficients are divisible by and will help bring us to lowest terms. So 12, we'll start with 12. We always check for 12 first to see if 12 divides into the other numbers evenly, if those other numbers can be evenly divided by 12 when we set a equal to 12. And they can be, because 12 divided by 12 is 1, and 24 divided by 12 is 2. So this is how we bring everything to lowest terms. So if we divide all the coefficients by 12, right, and we can do that because we're only looking for a proportion, not actual values. We're looking for a proportion. So divide everything by 12 to get lowest terms. A ends up being 1, b is 2, x is 1, y is 2, and z is 2. And this here gives us the final coefficients that we need to balance our overall equation. So then the last thing that I do is I go back to the top, I get rid of my placeholder variable coefficients, and I replace them with the coefficients that I solved for. So we don't need to you never need to put a 1 in front of any compound in balancing an equation. You never need to do that. I'm just going to do it for the sake of clarity here. So 1 sulfuric acid, 1 molecule of sulfuric acid reacts with 2 molecules of sodium bicarbonate to produce 1 molecule of sodium sulfate and 2 molecules of carbon dioxide and 2 molecules of water. And then that there ends up being our final overall balanced equation. And we solved this balancing chemical equation problem using the algebraic method. So I hope that this was helpful for you guys. Please let me know, obviously, if you have any questions. And you can always email me or come to one of our virtual classroom meetings.